All right, hello 8th grade scientists and welcome. Get ready because today we're stepping into the fascinating, sometimes kind of messy, but absolutely essential world of evaluating experimental design. I'm so incredibly excited to be your guide for this explainer as we learn how to look at an experiment, whether it's yours or someone else's, and figure out if it's actually built to find the truth. We're going to learn exactly how to spot weaknesses, suggest some brilliant improvements, and truly understand how science works behind the scenes. 1 Corinthians chapter 14, verse 40 tells us, "Let all things be done decently and in order." Now, you might be wondering, why are we talking about this in a science lesson? Well, it's because order is literally the absolute bedrock of science. Without order, an experiment is just a random, chaotic series of events. When we design an experiment decently and in order, we're creating a structured environment that allows the truth to clearly reveal itself. Order in our design is what gives us total integrity in our results. Okay. Let's dive right into our roadmap. First, order in experimental design. Next, defining our variables, followed by why we must trust our results. Then we'll fix some flawed experiments before zooming out to the bigger picture, which is godly learning. Section 1, Order in Experimental Design. The big idea you really need to hold on to today is quite simple. Good experiments must answer very clear questions, and they absolutely have to tightly control variables to produce reliable results. Moving right along to Section 2, the what, defining our variables. Before we can evaluate or fix an experiment, we have to know the language of science. Let's start with the manipulated variable. This is the single factor or condition that is intentionally changed in an experiment. I want you to picture your own science fair project for a second. What is the one specific thing you are actively changing to see what happens? Well, that's your manipulated variable. And the key word here is single. For true order, we only ever want to manipulate one thing at a time. Next up, we've got the measured variable. This is the response or result that is measured in an experiment. If the manipulated variable is what you change, the measured variable is what you're writing down in your notebook. It's the outcome. It's the exact data you track to see the effect of whatever it was you just changed. And finally, we have our constants. These are the conditions that are kept exactly the same throughout the entire experiment. And listen, this brilliantly illustrates the ultimate secret to a fair test. If you don't keep everything else identical, how will you ever know if your manipulated variable caused the change, or if it was just something else entirely? Constants are basically the guardians of order in your experiment. Which brings us to Section 3, the why, trusting your results. Why do scientists obsess over these variables? Well, the stakes are actually quite high here. A poorly designed experiment is a massive waste of time, energy, and resources. But worse than wasting time, a bad design gives you misleading or completely false results. Think about it. Bad data is actually way worse than no data at all, because it tricks you into believing something that simply isn't true. That's exactly why scientists must use critical evaluation to spot weaknesses. When you have a strong, highly controlled, orderly design, it builds absolute trust in your conclusions. You can stand by your findings with total competence. So, how do scientists actually ensure this confidence? They use a mental checklist to bring order to the chaos. Here are your 3 essential steps. Step 1, look for clear variables and constants. You need one manipulated variable, one measured variable, and strict constants. Step 2, check for controls. You need a baseline group to compare everything against. And step 3, assess repetition. Did you do enough trials? Because one try is never, ever enough in science. All right, Section 4, the how, fixing flawed experiments. Let's take that 3-step checklist and apply it to solve a few real-world scientific mysteries. Here's our first mystery. Imagine an experiment testing plant growth in different types of soils. The setup has some great strengths, right? They're using the exact same plant type, the exact same amount of light, and the exact same amount of water. But there's a huge flaw. They planted the soils in completely different pot sizes. Why is that a problem? Well, because different pot sizes could completely change how the roots grow, throwing off the whole experiment. The brilliant solution here is simple. Use identical pots. Make the pot size a constant, and boom, order is restored. Let's look at mystery number 2. Someone is testing a brand new fertilizer on tomato plants. They measure the growth, and wow, the tomatoes get really big. But here's the problem. They didn't include a group of tomatoes with no fertilizer. Without that, there is absolutely no baseline to compare the natural growth against. I mean, maybe it was just a really good season for tomatoes. The solution is to include a control group, plants receiving 0 fertilizer. That baseline group instantly proves whether your manipulated variable is actually doing the work. And mystery number 3. Let's say we're testing student reaction times, but we only take one single measurement per student. The major weakness here is random error. What if the student blinked exactly when you measured? Or what if they sneezed? Taking only one measurement risks capturing a total fluke. The solution to bring order to this data is repetition. Take multiple trials for each student and average the results together to find the true, accurate number. Actually, I want to pause right here and pose a question directly to you. And hey, just between you and me, this is one that you might just see on your homework. Why do more trials usually lead to better data? Think about what we just discussed with the reaction times. I really want you to actively recall this. More trials smooth out the random errors and mistakes. They give you an average that reflects reality rather than just a one-time accident. Finally, Section 5, the bigger picture, godly learning. Because at Hero Smart Academy, we believe learning goes far beyond just memorizing variables and controls. So the absolutely crucial point is this: education without morality will hurt. Think about an experiment again. If you make bad choices in your design, your experiment fails. It completely falls into chaos. Well, life works the exact same way. If you're incredibly smart, highly educated, and know all the scientific facts in the world, but you lack moral integrity, you're going to make bad choices. And bad moral choices, despite having a great education, will ultimately hurt your life and the lives of those around you. But there's a better way, a way of true order. Romans chapter 8, verses 6 through 7 offers a really beautiful promise: peace of mind to everyone who keeps their mind spiritual. And guys, this is the ultimate positive result we're all looking for. When you intertwine biblical morality with your education, when you live a life of spiritual order, the result is deep, lasting peace of mind. I want to leave you with this final, thought-provoking question to reflect on today. What is the point of being smart and supposedly educated if you continue to make bad choices that hurt? Remember, order and integrity aren't just rules for a science lab. They're the absolute foundation for a good, truthful, and peaceful life. Thank you so much for joining me for this explainer today. Take these lessons, design your experiments well, and most importantly, design your life with integrity. I'll catch you next time.